While DCC systems typically say only 2 wires for the track, eventually if you want the most out of your DCC system, you will need to work with the throttle bus. And it is a great skill to be able to work with and create your own throttle bus cables. Now, while you can buy cables, especially from hobby shops that specialize in DCC, a lot of these are going to be a common length, 3 feet, 4 feet, 5 feet, 10 feet. But what if you need something that's 6 inches long, or maybe you need something that's 25 feet? There, you're going to need to be able to make your own custom length cables. It's not complicated to do, but you do need the right materials and know exactly how to put it together. While we're looking at a Digitrack system, all this work is also compatible with NCE as well. Now you may be thinking, well, why I'm going to use radio control? I don't need a DCC. I don't need a throttle bus. Well, to go from a system, the main command station, which is Digitrack Zephyr, is a combination throttle and command station. You are going to need at least one cable, one DCC cable, to get from this command station out to the radio receiver. Also, if you plan to use things like a throttle bus controlled fast clocks or other types of accessories, they also may require a throttle bus type of cable. You're still going to have to deal with it. For my examples, I don't use radio control on my layout. Everything is through connector panels and these cables. The first thing to note about a DCC throttle bus cable, and this is especially a caveat to note if you're buying these not at a hobby shop. If you note that this is a short cable, you note the retaining clip here is up on top. And if I were to go across the whole length of the cable, keeping everything the same orientation, when I get to the other end, note the cable clip is at the bottom. This is known as a reversing type cable. And note this wire is RJ12. So this is a flat wire phone cable, was typically used for a business type multi-line phone systems. It's not to be confused with the smaller RJ11, which is a 4-wire cable used for landlines in homes. Make sure if you're picking up used cables, things like that, you have a 6-conductor RJ12 wiring. One thing I have found, and I'm working here, is that converting, building a smaller layout from the larger layout I had, is that I have frequently found that the cables, they tend to be, they're really, like this one, way too long for an application, or they might be like this guy, maybe way too short for an application. So again, that's custom lengths are very handy. One thing, create your own cables. You're going to need first is a stock of wire. Generally, if you can find the electronic supply stores and buy bulk RJ12 wire, it's probably the best thing you can do if you can find it. And I did casually look on Amazon. I did not see any bulk wire. However, you could buy some commercial 25-foot cables again and just use one end of the cable and cut the other end off as an example. So if you buy commercial with the ends already on it, you're just going to want to make sure that you get the longest cable possible to reduce the cost per foot. You're also going to need a supply of RJ12 6-conductor connectors. These are crimp-on connectors. These are not, they don't cost that much. You usually get a dozen, 10 or dozen. I picked up these bulk years ago, same time when I bought the cable. But you can buy them, and you can still find these find these today. Lastly, this is going to require a specialized tool. This is a combination cutter, stripper, and crimper specifically for RJ12 wire. Now these you can still buy. You can still buy these. In fact, they seem to be cheaper than they were. I remember when I bought this about 25 years ago. I remember thinking, well, that's an outrageous price for this. It was like $40 back in 25 years ago. Now you can still buy them for less than that. I'm seeing a lot of them in that $20-$30 range. Plus, some of these now are also have the crimper module is a bit different to allow also to use for the larger RJ45 crimp-ons, and that is the same size. That's what you need for Ethernet. So you can use these same techniques to create your own Ethernet cables. Then we also need a cable tester, and this is one that Digitrex uses. Some other manufacturers offer them straight as is. It's just a place to plug in the cable, and then it has LEDs that light up and shows you if it's if it's good. Yeah, so here I have plugged in a known working cable into my Loconet, one of my Loconet ports, and I just plug this into the other end, and we'll see that we have these three lights, and this is a working cable. So all these are workable. And Digitrex has mentioned if you don't have a throttle plugged in, generally if the track bus is not active, you're only going to get 3 of the 4. If I plus the track bus in, you see there's the 4th light. But the 3 here, this shows this is a known working cable. So what we will want to do is test everything to make sure that it works before you put it into place. And if you don't have a working cable, this is an extra cable that I had. Obviously, if you've not made any ones before, if you have something like one of these UT6 type throttles, they have a detachable cord, and so this is a detachable spiral length cord. This also is a Loconet cable, so you can plug in one end and check the other end on the decoder tester and see what lights light up on it, and know, okay, this is a good master to follow. And I'm going to demonstrate through one of these, and this is this extra super long cable here. It's too long for what I need it for, but I'm not going to create a whole new cable where I can just use part of it. Mark this where I'm going to cut it. And it's important to note that for the cutter ends, one of the most important critical pieces of this is to make sure this cutter is when you cut the cable, it's perpendicular to the end of the cable. So you want to make sure that it's straight as possible. You may have to do some retrimming on it. What we want to do is cut this to the right length. You want to keep that as straight as possible. The jacket is important to be straight as possible. If you cut this at the jacket end at an angle, when you try to stick it into the connector, it won't go in all the way, and therefore it also means that the wires that are stripped at the end of this will also not go in all the way, and you will have a bad connection. The next piece to do is strip the end of this wire. But again, this is one we require the tool. You really can't use a knife or something like this because you will damage the wires at the end, and if they won't fit into the connector right, there's a good chance it won't work. So the stripping function is done by these 2 blades here. And if you note here on the end of there's a little stop here at the end of the stripping stop here. This is basically you push the insulation wire against this edge, the cut flush edge. This will automatically keep your the stripped length at the appropriate end. So we want to just put it in there, right there on the right side, and then we're just going to put it right next to stop. Put it on the right side, keep it nice and straight. And we're going to cut this, and you're going to end up stripping it like this. Then you'll have, and again, it just pulls the insulation off. And then lastly, we're going to want to take one of these connectors out from our supply. And then the connector, the crimp function here, it just clips snaps in to the tool. Now you are going to have to make sure that your, again, your wire is oriented. So note the white wire here is on the left. So we had to turn this thing over, and so that white is on the right. We stick it when we stick it into the tool when the clip is down. Then you'll note is that if you feed it in, and you just push the wires go in themselves, and we just push you're gonna push the insulated portion in till it stops. It'll go in a bit. You push until it just stops, doesn't go any further. Then we squeeze tight squeeze on the connector. And then we release with the cable. So that at that end looks to be an appropriate cable end. But again, we're not going to know until we plug it in. So plug it into our unit. And then we'll plug it in the other end into our cable. And there we go. We have the same three lights light up. And we get the fourth light with the power on. So this cable is known to be good. So this shows that it takes very, very, very little time to create your own custom length cables without too much muss or fuss, as long as you have the right tools and supplies. So to be notified of more of these how-tos and tip type videos, please subscribe, and thank you for watching.